Okay guys, now the turn is factor a difference of the square. Factor a difference of the square. The difference of the square. That is the way how we need to solve it. And we are going directly to analyze several exercises applying these properties or this method. Remember, it's a binomial difference of the square. Let's go to solve exercises. The difference of the square, guys, looks like this. Is a to the square minus b to the square in general terms. That is a to the square, b to the square, the difference of the square. And when we solve it, that difference of the square, our answer will be a plus b times a minus b. In other words, the product of the addition by the difference between two terms. And the factorization of the difference of the square has that style, and we are going to solve a couple of the exercises applying the same formula. Determine who is a, who is b, and then determine who is the solution for the difference of the square. For example, the exercise 16x to the square minus 81. If we can determine if that couple of terms is the origin, if comes from the square one expression, we are in presence of the difference of the square. Let's to check if the first term we can transform in expression with the square, and the second term the same thing, to the square. That means relation of our letters, a could be for us equal for x, and b could be equal 9. To solve this difference of the square, just apply this expression, and we have the answer. Then parentheses, the first term is for x, which is a, for x right here, the same x. One is positive, which is 9, and one is negative, which is 9. The factorization of this expression is a plus b, a minus b in general terms. Okay? Okay, guys, the following exercise don't look like the difference of the square, because the first term is not the square, and the second term 8 is the origin of the a is not the square. But pay attention that perhaps we need to consider always the main instruction when we are factoring polynomials. In that case, again, check if you want factoring for any GCF, for any common factor, the expression that you have. In this case, you can factor for 2, and then you get the following expression. 2 as a common factor of 25 minus 4x to the square. And clearly, the expression inside the parentheses we can represent by the square of factors, like this. Then we have 2, and then bracket in that case, 5 to the square minus 2x to the square. Then we have right here the difference of the square, Then, if for us it's clear how we solve the difference of the square, remember the formula, the difference of the square is a plus b, a minus b. Directly we can say that our product is 2, then multiply a plus b, a is 5, plus b, which is 2x, and 5 minus b, which is 2x. And ready. Instead of 2 factors, now we have 3, because previously we take the GCF, the common factor of this expression. This expression. Okay, then be careful. Let's solve another exercise. The following exercise, guys, has only one intention. Let me write the exercise. The exercise is 3x to the square plus 27. The only intention is that you avoid confusion. To avoid that you are confused, the only thing that you can do in this exercise is apply the GCF, the common factor. The common factor in that case is 3. 3 is common factor of x to the square plus 9. It's true that we can say that this term is a square and the other term is a square. 3 to the square, x to the square. But the point is that we can try this exercise as a difference of the square, because a to the square plus b to the square in general term is not factorable. The sum of the square is not factorable. Then the only that you can do is that expression, common factor 3 of the parentheses that you see. Okay, guys.